Deep neural networks learn to recognize patterns in a test dataset through a process called training. Here's an overview of how this process works. Pradeep K. Suri, author and researcher. 1. Data preparation. The first step in training a deep neural network is to gather and pre-process a training dataset. This dataset consists of input data, example images, text, numerical features, and their corresponding labels or target values. This dataset should represent the patterns that the network is supposed to learn. Additionally, a test dataset is typically set aside for evaluating the network's performance once it's trained. 2. Initialization. The neural network is initialized with random weights and biases. These weights and biases are the parameters that the network will adjust during training to capture patterns in the data. 3. Forward propagation. During training, each data point in the training dataset is passed through the network, and the network calculates a prediction. This process is called forward propagation. The prediction is then compared to the actual target value, and the difference between them, the loss, is calculated. The goal is to minimize this loss. 4. Backpropagation. Once the loss is calculated, the network uses an optimization algorithm, example gradient descent, to adjust its weights and biases to reduce the loss. This process is called backpropagation. The gradients of the loss with respect to the network's parameters are computed, and these gradients guide the updates to the parameters. 5. Repeating the process. Steps 3 and 4 are repeated for many iterations or epochs, with the network learning from the training data by gradually adjusting its parameters. As this process continues, the network becomes better at making predictions on the training data, and it starts to capture patterns in the data. 6. Validation. To avoid overfitting, where the network learns to memorize the training data but doesn't generalize well, a separate validation dataset may be used to monitor the network's performance during training. The validation dataset helps in selecting the best model and preventing it from learning noise in the training data. 7. Testing. Once the network has been trained, it is evaluated on the test dataset. This dataset is not seen during training and is used to assess how well the network generalizes to new, unseen data. The network's ability to recognize patterns in the test dataset indicates how well it has learned from the training data. 8. Fine-tuning. Optional depending on the performance on the test dataset, the network may be fine-tuned by adjusting hyperparameters, changing the network architecture, or increasing the amount of training data. Deep neural networks, such as convolutional neural networks, CNNs, for image data or recurrent neural networks, RNNs, for sequential data, excel at learning hierarchical representations of data, allowing them to capture complex patterns and features. The network's ability to recognize patterns in the test dataset is a measure of its generalization and effectiveness in solving the specific task it was designed for. Deep neural networks, DNNs, can be used to create sales forecasting models for a wide range of businesses and industries. The type of dataset you would use for training a DNN sales forecasting model depends on various factors, including the nature of your business, the available data, and the specific sales forecasting task. Here are the key types of data that are typically used in sales forecasting models. 1. Historical sales data. This is the most fundamental data for any sales forecasting model. It includes records of past sales, broken down by time periods, example daily, weekly, monthly, and often by product or category. Historical sales data is crucial for understanding sales trends and patterns. 2. External factors and features. Depending on your business, various external factors can influence sales. These might include economic indicators, example GDP, inflation, weather data, holidays, promotions, and marketing campaigns. Incorporating these external factors as features in your dataset can improve the accuracy of your sales forecasts. 3. Product or service information. Details about the products or services you are selling, such as product attributes, example price, brand, category, availability, and any changes in product offerings, can be valuable in making sales predictions. 4. Customer information. Customer data, if available, can be useful for personalized sales forecasting. This might include customer demographics, purchase history, and customer behavior data. 5. Market research data. Information from market research or customer surveys can provide insights into customer preferences, market trends, and potential changes in demand. 6. Competitor data. Data on your competitors' sales and marketing activities can be used to gauge how external factors might impact your sales and to adjust your forecasting accordingly. 7. Time-related features. Time-related features, such as seasonality, day of the week, and time of day, can play a crucial role in sales forecasting. DNNs are well suited to capture these temporal patterns. 8. Inventory and supply chain data. For businesses dealing with physical products, information about inventory levels and the supply chain can be important. Stockouts and supply chain disruptions can affect sales. 9. Geographical data. If your business has multiple locations, geographical data can be essential. It might include information about the location of stores, warehouses, and customer locations. 10. Social media and online activity. For businesses with an online presence, data on social media activity, website traffic, and customer interactions can provide valuable information for forecasting. When creating a dataset for a DNN-based sales forecasting model, it's essential to pre-process and clean the data, handle missing values, and engineer relevant features. The choice of features and the architecture of the DNN can vary depending on the specific sales forecasting problem you are trying to solve. Additionally, the quality and quantity of the data, as well as the model's training and evaluation processes, will influence the model's accuracy in making sales predictions. Thank you.